Welcome back. In this explainer, we're setting a course for the absolute edge of human understanding. We're preparing to explore an anomaly that literally bends the rules of reality to a breaking point. And you know what makes this destination so profoundly unsettling? It's not just its destructive power. It's the fact that it is completely, utterly invisible. So prepare yourselves because we are heading into the dark, and what we find there is going to challenge absolutely everything we know about physics.
All right, I want you to imagine something with me. Picture a doorway suddenly opening up right here in our solar system. But actually, scratch that. This isn't your ordinary spatial rift. It's a region where infinite space-time curvature dictates that distance itself just completely ceases to make sense. It's an abyss where the escape velocity is faster than the speed of light, meaning even photons are trapped forever. So what actually happens if a human falls in? Do they just die? Do they cross some kind of cosmic bridge? Or are they converted into pure information?
Now, the most unsettling part of all this isn't that these cosmic anomalies exist in some far-off, distant corner of the universe. No, it's that astrophysicists estimate there are literally millions of them lurking right now in our very own Milky Way galaxy. Millions! These aren't just abstract math concepts on a chalkboard. They're the invisible, silent remnants of ancient stars just waiting patiently in our cosmic backyard. And to truly grasp the threat they pose, we really have to look at the violent mechanics of how they're born.
So you probably know the basic origin story, right? A massive star exhausts its nuclear fuel, it finally loses the billion-year war against its own gravity, and boom, it goes supernova. But it's the immediate aftermath of that cataclysmic explosion that just completely defies logical comprehension. The leftover stellar core collapses under its own staggering weight. It shrinks right past the point of atomic resistance, compressing an unfathomable amount of mass into a singularity. We're talking about a microscopic point in space with near infinite density and zero volume. Mind-blowing, right?
Now, the term black hole is actually a bit of a misnomer. We aren't talking about an empty void or a literal hole punched into the fabric of space. Not at all. We're dealing with an object whose gravitational pull is so immensely powerful that the escape velocity required to leave its surface is greater than 300,000 kilometers per second. And since literally nothing can travel faster than the speed of light, well, nothing can escape, which renders the whole thing effectively invisible.
But the true terror of this anomaly? That lies in its strict mathematical boundary, famously known as the event horizon, or the Schwarzschild radius. This isn't some tangible physical surface you could reach out and touch. It's an informational boundary, a threshold where space-time curvature gets so incredibly extreme that all possible outward trajectories just simply cease to exist. Once any matter or light crosses this invisible line, that's it. It is permanently severed from the rest of the observable universe.
Let's make this theoretical physics a bit more personal, shall we? Imagine you're in a spaceship, actively falling toward an event horizon. What's deeply, deeply unnerving about this is the eerie silence inside your capsule. Because you're in freefall, the laws of physics dictate that you wouldn't feel any immediate g-forces at all. You'd feel like you were just peacefully floating, completely unaware that you were barreling straight toward the most violent, uncompromising object in the entire universe.
And here's where it gets really weird. Because of extreme time dilation, an observer back on Earth wouldn't actually see you fall in. As you approach that massive gravitational well, they'd see your ship's image deeply redshift as the light literally struggles to escape the pull. To them, your movements would slow down to a crawl until you appeared to just completely freeze at the edge of the horizon. Forever. Yet from your own perspective inside the ship, time is flowing completely normally as you plunge directly into the dark.
As your ship pushes even closer, the view out your front window becomes terrifyingly surreal. Directly ahead of you is absolute, pure darkness. But around that void, the surrounding stars of the galaxy appear to be violently bending and twisting. Because photons are forced to orbit the black hole multiple times before they ever reach your eyes, you're essentially looking at infinite, recursive, heavily distorted copies of the entire universe. It's like staring into a giant, shattered mirror made of broken glass.
This twisted view is what we call extreme gravitational lensing. The singularity's mass is so unyielding that it acts like a cosmic magnifying glass, physically bending the path of photons traveling from galaxies billions of light years away. You are literally watching the very fabric of space-time warp in real time. But look, while the visual distortion is absolutely fascinating, it's really just an optical prelude to the catastrophic physical forces that are about to act upon your ship.
Because now, the cosmic light show ends, and the brutal physics of extreme tidal forces take over. Since you're in a profoundly steep gravitational well, the pull of gravity isn't uniform across your body. Say you were falling feet first. The gravitational gradient is so steep that the force yanking on your feet would quickly become exponentially stronger than the force pulling on your head, and that creates a fatal differential.
Astrophysicists actually have a name for this gruesome reality, and it's kind of morbidly playful: spaghettification. The extreme tidal forces would violently pull you from both ends. The closer you get to the singularity, the more these forces would overwhelm the actual molecular bonds holding your cells together. You'd be stretched into a long, incredibly thin shape, right up until the very atoms comprising your body are violently pulled out of alignment, completely atomizing you and your ship.
But you know, physical destruction is really just the beginning. The deeper, arguably more terrifying question concerns the quantum data, the fundamental information that makes you, well, you. When your physical matter is destroyed and pulled into the dark, what happens to the blueprint of those atoms? The data of your ship, your body, your memories? Is that quantum information stored somewhere inside the singularity, or is it just permanently erased from the cosmos?
And this brings us to the absolute greatest mystery in modern physics, the black hole information paradox. See, quantum mechanics dictates a very fundamental rule. Information about a physical system can never be permanently destroyed. Yet Einstein's theory of general relativity suggested a black hole consumes everything flawlessly and permanently. Both fundamental pillars of modern physics literally cannot be right at the same time. For decades, this irreconcilable paradox just tormented the world's brightest minds. For years, theoretical physics was at an absolute standstill over this. But then Stephen Hawking looked closely at the quantum thermodynamics happening right at the edge of the event horizon. Through some incredibly complex mathematics, he delivered a paradigm-shifting revelation that challenged the very nature of these cosmic traps. He declared a seemingly impossible truth to the scientific community: black holes are not entirely black. Hawking realized that the extreme gravity at the event horizon causes virtual particle pairs to just spontaneously pop into existence. One particle falls in, but the other escapes, meaning black holes actually leak a tiny amount of thermal energy over time, a phenomenon we now famously call Hawking radiation. And because they're constantly leaking, well, given enough trillions of years, a black hole will eventually evaporate and vanish entirely. But wait, if it vanishes, we're right back to our paradox. Where did all that trapped quantum data go? This single question forces us to rethink our entire understanding of reality. If the fundamental laws of physics break down at the singularity, and if quantum information somehow survives, could this incredibly dense object be something else entirely? If data isn't destroyed, it suggests a black hole isn't just a stellar graveyard. It might fundamentally rewrite our understanding of traversing the cosmos. Could it actually be a hidden cosmic door?
Think about it. When you pass the point of no return, when your matter is broken down into pure quantum information, what truly lies on the other side of that absolute dark? Could the singularity actually be an Einstein-Rosen bridge, like a literal wormhole connecting two totally disparate points in spacetime? Could all the matter and data consumed by the black hole simply be spilling out into a completely different, unimaginable universe?
Or is the truth much colder? Is there no gateway, no grand cosmic recycling system, and no secret parallel universe waiting on the other side? Could crossing the event horizon simply mean plunging into a crushed dead end of reality? Just an eternal, crushing abyss of infinite darkness where time stops and existence simply ends?
Well, in part 2 of this explainer, we're going to cross the event horizon together to explore the math behind wormholes, the hypothetical existence of white holes, and the ultimate fate of the universe. So, until then, I want you to ask yourself, if information truly cannot be destroyed, what exactly is the universe trying to hide in the dark? See you in part 2.